Hey, what's up, guys? So let's say you've got a new microcontroller board you just designed and you used an AVR for this. An Atmel or now microchip AVR based microcontroller. Very common on the Arduino boards. In fact, what you're looking at here is a board I designed and sell up on Tindie. That is just a simple breakout board for the AT-Mega 328P. And if you had to program a whole bunch of these, which I do, I load each one of these with test code. I also have to burn the AVR fuses and load the Arduino bootloader into every single one of them so that you can then program it from the Arduino IDE. So if you had that same kind of thing where you had to do all that, you might be interested in this board here, which is something I designed and what we're going to talk about in this video, called the AVR Programmer. So it was designed specifically to program AVRs using the ICSP programmer interface in circuit serial programming, and it has a lot of cool features. So the way this works is it takes the compiled hex file that you load into this SD card here and loads that over to the target microcontroller. It sets the fuses for you, but it also does something else that's very interesting. It can read and write to the non-volatile memory on the part. So the EEPROM in the part you can read and write to from this board, which means now you can create sort of a little GUI from the serial interface to this board. So you can open up a serial monitor window, for example, and read and write to memory locations on the chip. So one very useful way, to actually use this is to set modes. So like, let's say you've got a whole bunch of boards and they all, it's all the same physical board, but when they boot up, you want them to boot up and do different things, different modes for each board. You can do that because you just burn in the mode into a byte in that EEPROM somewhere, so when it boots up, it checks that and says, oh, I'm supposed to be this or that or whatever. And of course, you can load in serial numbers and MAC addresses or date codes, all kinds of different things. And I actually have a pretty cool example here to show you of how this whole thing works. So let's just jump right into that right now. Okay, so I have a serial monitor window opened up here, and this is actually connected to the AVR board. And I'm going to go ahead and just take a brand new board here from my 328 inventory, and we're going to hook up the in-circuit serial programmer cable to it. Let's get that right. There we go. So we're plugged in. The board powers your target microcontroller board as well. And it gives us a few options. We can read board information, we can write parameters or a brand new board programming. Or we can just hit the blue button, which is what I'm going to do. So I hit the blue button, it's burning the fuses, it's also burning that sketch, and there we have it. Now it wants us to enter in a date. So I'm just going to actually copy this date out. It needs the full 8 digits. We also give it a carriage return here, and then we hit enter. And it takes that, and it basically just burned that date into memory. So now, reading from board, you can see it shows the fuses that it used. It also shows the date that we burned into it, and then also a firmware date code, which is kind of cool too. So this is a date code that is burned into it from the sketch side. So we just loaded code into it, and then that sample code actually wrote to the EEPROM as well, so that now anytime in the future, like let's say you had a return, you could plug this up to this board here. We can hit R, and now we read from the board, and we can see the date code and also the firmware date code. So just kind of an example of showing the kind of communication you can get with this platform. And here is that test code that I just loaded on to that SD card. So you can see here what it basically does is in setup check to see if at memory location 8 in the EEPROM if it's empty. And if it's empty, then it loops through and loads that date code. It does a dot write to those 8 locations for the full date. And this again is in the sketch, so it could be like a firmware version or something like that. And again, this is just kind of an example of how you might want to do this. So that's how we're able to, from the sketch, to write to that memory, and then the AVR programmer board can read it back out, which is kind of nice. And then right here in the loop, it just loops through and prints this to the serial monitor window. So the way you do this then to get this onto an SD card is go to Sketch. Well, let me back up, because first you obviously have to make sure you have the right target. And for my board, I use the Arduino Mini 328P, and then that's it. That's all I do. And then I go to Sketch and Export Compiled Binary. So you do that, let that do its thing. It's going to compile it, and then when it's done compiling, you can then go to Show Sketch Folder, and then it opens up the sketch folder. And then what I do, let me get rid of some of these other files here, delete those out. I use this one that's with bootloader, and then the way my code works is it looks for a file, one file called firmware.hex, and then I just drag that straight onto the SD card, and then it will know to look for that file and use it. Again, we're using the bootloader with this, so this includes that. Okay, so that's everything you need to know about actually working with the board. Now let me just quickly give you a little background here on the design of it. So the board gets its power from the USB to serial converter that's hooked up to the 6-pin. It's a standard FTDI header, 5 volts, 5-volt logic, and then we level shift that down. And the reason for that is because I want the full 5 volts available to me here, because we're also powering the target board as well from that 5 volts. So then through the 5 volts, we regulate down to 3.3 volts, and then everything else on the board is at 3.3 volts. So we're using 3.3 volts on the SD card logic levels, and then also the target AVR is at 3.3 volts. But of course, it should be compatible with other logic levels as well, like 5 volts, because we have a lot of protection here. So if you look down here, you see that we're powering it through a fuse, which is cool, and then also a diode which blocks it in case, this is at 5 volts. If your target AVR is at 5 volts, it blocks it and you won't have any shorts then. And then on every signal going to the target microcontroller, you've got inline series resistors which limit current in case you've got any shorts on any of the pins. And then also clamping diodes, which again kind of prevent any overvoltage conditions on the AVR programmer or anything else, any other failure modes that you might have. So that's the purpose of those diodes there. And again, I'm not really too concerned about failures on the microcontroller board, because the target board, because that's the board under test. I expect it to have failures. I just don't want to blow this board up. So that's why we have these protections in place. And then of course, you've got your 3 LEDs, your 2 push buttons. The blue one is really the only one tied back to the microcontroller. The red one just resets the whole thing. So if anything were to lock up or whatever, you just press the red button, it reboots it. And the reason for that, of course, is a lot of the fault conditions are going to be could not communicate to the target AVR, or couldn't load code off of the SD card. So in that case, you'd want to reboot anyway so that it could reinitialize and communicate to the SD card. There's also a buzzer on there, which is kind of handy, especially if you're programming something huge. You can just hit the go button and then walk away and come back when you hear it beep at you. So then this configuration is pretty standard for just a standalone Arduino setup running at 16 megahertz, all through-hole parts, by the way, so it kind of keeps this thing easy to build. And that was kind of the whole point of this board, easy, and if anything fails, you can rip it out, replace it, and so that's pretty much all there is to the hardware. And there's a wiki page for this board too, which I'll continuously update, and if anybody does expand on this project at all, I'll also post those updates there. Okay, so then I want to go here first before I describe the firmware at all, or at least kind of show you how that works. because this is really the heart and soul of that firmware base that I'm working with. It actually 99% of the code is based on Nick Gammon's project here, and he has a page for it for the Standalone Programmer. So it's very similar to what I did. In fact, I started here and built up and replicated what he had done here, which does exactly the same thing, loading code onto a target microcontroller from an SD card. And then even if you go down a little bit, there's an example of a custom PCB similar to what I did, where you can actually select what file you want to use. So you could have different images or hex files on your SD card. So that's kind of cool. But again, for me, I wanted it to be very simple, single button, kind of just go, program, and then also having that EEPROM read-write feature was also something I wanted to do. So let me jump over to the code now. Okay, so instead of going through this line by line, I'm just going to kind of explain how it is organized. And again, this is kind of an incomplete project because ideally I'd like this board to be compatible with all of the Arduino AVR based boards that you have available. So like the bigger Arduino Mega boards would be nice, but really it would be cool if the AVR Programmer board could figure out what it's attached to, and then based on that set the fuses properly. So I know it's possible, it's just, again, I pretty much stopped once I got it to work with the 328 board. So if you kind of go through this, it'll make sense. And again, not going to go through it line by line, but you know, obviously you have your setup and your initialization, and then in loop you'll see that it immediately goes to the GUI interface where it's kind of waiting for something to happen. And this is all of my custom code in here, the get user input. Everything from the Nick Gammon base code I threw into programming functions and this data.h file, which is like all the global variables and functions declarations in here. So and constants, and there's a lot of stuff going on. You know, there's a lot of cool features built into it, like the LED gives you a fault code, and based on how many blinks you get, you can kind of figure out what's going on. So, and you can dig through this, and you'll see that stuff in here. Okay, so then I'm just going to jump back here now. So I did have to change one thing here, so, and I have a comment here. So in order for me to get the bootloader, in order for me to get the bootloader to work properly, I did have to change this one line down here. And I kind of put it in there as a to-do to figure out later why I had to change that, like why this code didn't work. But I forced it at hex 7E00. And if you go into this, you'll actually see that is spelled out. Yep, oh, I just passed it. Right here, so for the 512-byte bootloader, the start address is 7E00. So I just had to force it. And then if you go over to the core libraries here, the core Arduino framework stuff in up on GitHub, you can go down and actually look at the 328P, you know, what they are actually burning those boards at. And I'm looking at the make file here for the 328 board. There's the 168. Here's the 328 right here. So this shows you what the fuses are. There's the high fuse, the low fuse, the extended fuse, and then they also show the 512 byte boot. So I did have to change that, and I forced it there. And then also, let's see, I'm going to go to get user input because I had to actually add in where I wanted those fuses, how I wanted them burned. So you can see there's my FF, DE, and 05. So that's where I'd take care of the fuses. And then if you go down a little bit, one of the things I sort of had to figure out a little bit was how to do the EEPROM read and writes. So, you know, and in this code is all of the protocol stuff for talking over that native AVR ICSP cable to your target micro. So I'd spent a lot of time actually trying to figure this out, and eventually got it to work pretty well. So, and you can look into this a little bit if you want to, but I just want to show you where it's at. So there's my burn, EEPROM there, and then there's probably something. Okay, so yeah, right here is where it actually does the readout of the EEPROM. So again, you know, I just kind of want to show you where it's all at, and everything else in this code is pretty self-explanatory. If there's enough interest, I will do a line-by-line deep dive, but because there's so much going on over here from Nick Gammon that I don't even fully understand, I honestly haven't gone through it yet. I'm not going to make that video just yet. So, and you're more than welcome. Again, if this is something interesting to you, I would be very interested to see what you come up with, especially if you go in here and make it better and make it more compatible with different boards and stuff. So, just feel free to reach out to me. There will be contact info in the description below. So anyway, that's pretty much all I've got on the AVR Programmer board. Hopefully you find that helpful. Thanks.